Right, so the next several days we're going to be working on operations with polynomials. Operations that we're going to hit are addition, subtraction, and multiplication, saving division for a little bit later because there's a little bit more to it. But polynomials, as you've seen through the vocabulary, a little bit different than just what we've been looking at with exponent rules in the past. So when we talk about performing operations on polynomials, the thing we need to keep in mind, and we've seen this before, adding or subtracting polynomials, we're combining like terms. We've done addition or subtraction before. We said things like 2x plus 3y equals 7. Okay, so I can't simplify that by adding 2x and 3y together because they are not like terms. So now what we've been doing, 2x squared times x to the 5th, we can combine those together through multiplication. But just a reminder, when we talk about like terms, what makes it a like term is not just the same variable, but that's part of it. Terms that have two criteria: one, same variables, and two, the exponents on those variables are the same. So same variables and same exponents. A lot of what we've seen is variables, but we've added, subtracted before. So I'm going to do a couple here, and you're going to get one to try. So starting out with the very basics, just a reminder, we've done this before. Harry Potter's and Hermione's was what it was in the video initially. But remember, when you say this is a term, this is another term that is like term with it. And then we have the plus 3y that is a term as well, a separate term. So we can combine the x's. So remember, we say we take the coefficients, 2x take away 7x gives us negative 5x's. And the 3y is still plus 3y, it's positive 3y, so we add it. So if you're talking about polynomials now, we have each of these, to get the vocabulary in, each of those is a monomial. The degree of them is the exponent on the variables. So both of those variables have an exponent of 1. So the degree of each of those monomials, two terms in the two terms overall, degree of each of those is 1. So the degree of the binomial, because this has two terms, is the highest degree overall, which is 1. So you would call this, based on what you have for your terminology, this would be called a linear binomial. You just have to interpret what each of those is referring to. The linear is talking about the degree. The binomial is talking about how many terms. So to move along, looking at these three terms, and terms are separated by addition or subtraction. We have an m squared n, we have another m squared n, and we have a third set that has that same exact variable, set of variables, and exponents. So that means all of those are like terms, and we can combine them together. So 10 and 4 would give me 14, minus 8 would give me 6 m squared n's. So because this is all multiplication in here, 6 times m squared times n, what we have here, this is a monomial. And to tell the degree of a monomial with more than one exponent, you add the exponents together. So the degree of this is 3. So degree 3, we call that from the chart on page 477, I think it is, cubic monomial. Normally we say the degree first, then the type terminology is, or how many terms. So you don't know the number of terms or the degree until you've actually simplified the polynomial. So adding or subtracting, you try this one. So pause, try it. Answer is, we have 2 sets of t squareds, and we have 2 sets of s squareds. So t squared minus 4t squared is negative 3t squared. 2s squared minus s squared, so that's minus 1s squared, gives us a single positive s squared left. And if you're interested, this is a degree 2, so this is a quadratic Each of those terms has a degree of 2, so the highest is a 2. Quadratic, and then there's 2 terms, so it's a binomial. I know I didn't ask you to name these, but just to get some naming in there. So while we were adding and subtracting terms, you can also do polynomial addition or subtraction by taking entire polynomials and adding them together. So what you might have seen for this particular problem, it might have started out as f of x equals 5x squared plus 4x plus 1. Maybe you have a second polynomial, a second relation, g of x equals 2x squared plus 5x plus 2. And what we're asked to do is take f of x plus g of x. What that's asking us to do is take the two polynomials and add them together. There's kind of two setups you can do, and you can decide which one makes the most sense to you. You can do this more in a vertical form, and so the idea is you take your first polynomial, and notice these are written in standard form, highest power to lowest power, quadratic trinomials actually, and you line up vertically your like terms. So 5x squared and 2x squared gives me 7x squared. 4x and 5x gives me 9x. And then 1 and 2 gives me 3. It's just a nice way to line them up vertically to make sure you're combining like terms only. You can certainly do it horizontally, and not my preferred method, but if it is yours, feel free to. You have your two polynomials, but then you use associative. Associative says you can group them however you like. Commutative says you can move the terms in the whatever order you need, and then you can get the exact same answer. So 7x squared, because those are like terms. 4x and 5x, again, gives me 9x, and 1 and 2 gives me positive 3. So you can use either format, but here's one for you to try that's maybe a little bit harder. So if you pause and try this, and now we look at it, the first polynomial, 5a to the third. What I notice is, looking at this polynomial, you have an a squared term here and an a squared term here. So I'm going to go ahead and just add those two together, because eventually that's going to have to happen anyway. 15a squared minus 6a. If I then look in the second polynomial, I don't have a full set of every type of term, but I do have some like terms here. So if I'm adding 7a to the third on, and I'm subtracting 10a, or negative 10a, if you want to put a filler in here, I don't have any a squareds, but I could put 0a squared. And now I can just combine my like terms. 5 and 7 gives me 12a to the third. 15 and 0 gives me 15a squared. And then negative 6 and negative 10 gives me negative 16a. This, if you want to name this, cubic. And it's 3 terms, so it's a trinomial, a cubic trinomial. And let's throw in some other terminology. I've written it in standard form. So the first coefficient here, the leading coefficient, is 12. Lots of terminology when we're talking about polynomials. Right now we identify the degree, we identify the leading coefficient. It doesn't tell us a whole lot, but in the future that'll be very essential to telling you. You can make a prediction of what this looks like on a graph just by knowing a few key pieces of information like degree and leading coefficient. Last one, so we've done addition. Now we're going to subtract polynomials. So again, if this was f of x and this was g of x, maybe you are asked to take the polynomial f of x and subtract away g of x. Okay, so this isn't necessarily super advanced from things we've done before, but if you notice the parentheses, I kind of ignored them on the addition problems. Why did I ignore them on the addition problems? Because what numbers are outside the parentheses? Well, outside of this one is a positive 1. I'm just going to put a plus 1 so we remember it's positive. But if you look outside the second parentheses, there's a negative 1. So when you think about combining these two together, when we were doing addition, there were just positive 1s outside. When you distribute a positive 1, that doesn't change anything. This is still 8x to the third plus 7x. But when you distribute that negative 1, this second polynomial becomes negative 2x to the third plus 3x minus 7. We have to distribute the negative into each term. So now when we combine them together, so I'm just going to rewrite this, 8x to the third plus 7x, and I'm going to line them up vertically because that's the way I like to do it. Negative 2x to the third is a like term. 8x to the third, 7x and 3x, so plus 3x, and then minus 7 doesn't have any like terms that it goes along with, so if you want to put a space filler there, just put plus 0. Now we can combine vertically. So 6x to the third, 10x's, and then minus 7. So there is your simplification. So one more set. You guys try, subtract the polynomials. Watch out for that negative. After you've paused, distribute the negative 1, and it's only being multiplied to the second parenthesis. So this is negative 5m to the fourth. Negative and negative makes that positive 5m squared, and minus 8. The biggest thing I see on these problems is people forget to distribute to all the terms in the second parentheses. So if we line those up vertical, 7m to the fourth has a like term right here, negative 5m to the fourth. Minus 2m squared has a like term with, oh, almost went to the wrong place, plus 5m squared. And then this minus 8, I guess I should have put a different shape. This minus 8 doesn't have any like terms to go along with it, so we are left with 2m to the fourth plus 3m squared minus 8. For the second one, distribute your negative 1. Oh, distribute your negative 1. That's minus x squared minus x minus 1. So 2x squared minus x squared, negative 3x minus x. Those are like terms, and positive 1 and negative 1. And what we're left with? X squared minus 4x, and the 1's cancel out. So it's x squared minus 4x. A quadratic binomial. So using the words more helps you get used to them, but adding, subtracting polynomials, it's like terms, and the thing that confuses people is when you think about doing this, m to the fourth times m to the fourth is not the same thing as m to the fourth plus m to the fourth. We looked at that example in class, but this is hopefully to help you solidify it. This is m to the eighth, but if you think about this, you're saying I have one m to the fourth, and I'm adding on another m to the fourth. So that means I have a set of 2 of them now. So polynomials, exponent rules, you've got to kind of build on them and keep them straight from each other and not let them overlap in your mind.